Okay, welcome everybody. Thank you for coming for my talk. And I want to introduce myself. First of all, my name is Jake Jacobsen. I am a U of A alumni. Graduated out of Roger Angel's group in 1997, and then went to work for a little company called Nikon in Japan. And since then, I've been a couple of other places, but in 2001, I landed in Optical Research Associates, doing Code 5 technical support, and from there I've been there ever since, which seems like a tremendously long time, but it seems to have gone by fairly quickly. So let me go ahead and share my presentation. Here we go. I think maybe everybody can see that okay. Is that good? Okay, if not, yell or something. All right, so the title of my talk today is Synopsys Optical and Photonics Solutions Groups. We're actually two groups now. 57 years of innovation in the simulation of light. So I want to give a little bit of history about Optical Research Associates, and now, which is now the Optical Solutions Group at Synopsys. They'll cover structure, and then I'll cover a little bit about our outreach program for students, as well as some career opportunities, the types of career opportunities that we have available, and some follow-up information on webinars that we are currently planning. Okay, so first, a very brief history of Optical Research Associates, consisting all of 2 slides. So back in 1963, a fellow by the name of Tom Harris was working for Bell and Howell in Chicago, and he was sent to work at the Jet Propulsion Laboratory with them, not at them, with the Jet Propulsion Laboratory on a joint project that Bell and Howell had at the time. It was a crazy harebrained idea that maybe you could take these newfangled things called computers and use them to trace rays and design lenses, rather than tracing rays by hand with a slide rule, which is really how it had been done up until then. And so he spent a couple of years out here in Pasadena, and then about 19, well, I guess it was 63. So I think he came out in 61. So 63. Bell and Howell said, no, well, okay, the project's over. Come on back to Chicago. And the story is that Mrs. Harris said, no, we're not leaving Pasadena. She liked the warm weather and didn't really want to go back to Chicago. So they put down roots here, stayed. He made some negotiations with Bell and Howell to get rights to the software in exchange for some additional work that he did. And then he took that software and continued on it over the next decade or so, and it eventually became Code 5, which was our first product, which was released commercially in 1975. Before 1975, part of the business was you could actually come out to Pasadena. You got on an airplane or a train, and you got to Pasadena, and you would run your you would work on the computer, which I assume is the one here in the picture on the right. You would work on that, and you would get these reams and reams. Would go back with your stack of papers and do your analysis. And he did consulting work for companies around here, a lot of defense companies here in Los Angeles area, and other companies across the country. And he did consulting, and he would write his program at night. This is what he used to put food on the table. And so they brought some people on board, which is how we got the name Optical Research Associates. And then about 1975, the software was mature enough that they felt it was ready to be released. Take the software, it was very customized, right? This is before Microsoft and the rest of it. And you would take a computer and they would bring it in-house, and they would bundle the software on it and ship it off to the customer for them to use at their home sites. And I've, for those who don't know, is specialized in sequential ray tracing primarily, and it's really tailored for its microscopes, telescopes, that sort of thing. And anyway, so slide 2. This is, like I said, a very brief history. And we expanded. The business expanded in 1995. ORA, that's Optical Research Associates, introduced a new illumination systems. This one was actually built up from the ground up as a 3-dimensional non-sequential spreadsheet kind of based. You have surfaces in a spreadsheet, actual capability to it, but for many decades it was very much kind of a spreadsheet tradition. Whereas LightTools was really built up as a 3-dimensional, more like a CAD package. Light can go any way you want. It can split, and you detect the lighting pattern that comes off of that. So it's really tailor-made for sort of nation applications and this sort of thing. And it was our first expansion offering from ORA. and it has grown steadily since 1995. So about 5-6 years after the introduction of LightTools. And then in 2000, Synopsys Incorporated, which is a very large software company. We'll talk a little bit about who they are and how and what they do in just a minute. The Optical Solutions Group, which wasn't a horrible thing at the time. ORA was actually an employee-owned company who were working here at the time, which is very nice. So we were all basically co-owners of the company. So following the 2010 acquisition by Synopsys, of course, then you have a lot legal, which is important when you're doing kind of acquisitions. And so we were able to rapidly expand. 12, we acquired the RSoft Design Group, which is based in Austin, New York. They're the makers of RSoft and Photonic design and simulation software tools. Basically, it's things on a very small scale, very different thing than ray tracing, right? But they're complementary. So we have very small sort of objects that they can't. And then so that old duality thing, right? And then we have another group of software which is specialized on, of course, because of computational limits, really limits the size that you can access in a practical sense. So a very small domain sort of devices. Into H, which is based in Paderborn, Germany, and there, which is a little town sort of in the northeast or westish of the country, not far from the Netherlands. And they are makers. This is actually very much like LightTools. It's kind of a 3D CAD sort of thing, but it's really focused on lighting design for external lighting for automotive. There's a lot of specialized tools and regulations and techniques that the lighting designers use in the auto found and a lot of the other lighting applications that you might run across. And it's very specialized and it's very important because you have to meet these rather rigorous and sometimes kind of odd regulations. And so you need tools that can help you not only do the design, but figure out if you got the design right. And that's a big part of it. We acquired a company called Phoenix Software, and they're the makers of OptoDesigner. I'm getting a message. My internet is unstable. I'm hoping I'm okay. So raise your hand if you can't hear me properly. So in 2018, Phoenix Software was makers of OptoDesigner. Now, OptoDesigner is kind of a very different thing. It's basically a commercial tool for photonic integrated circuit layout and verification. And so this is there's a new and emerging field which is concentrating on the use of photons in integrated circuit chips. So instead of electrons making computer chips, they're using photons for making computer chips. But when you do that layout for those sorts of chips, it's a very different rule set because photons don't behave like electrons. Electrons don't have any problem, for instance, with right angle things, but photons have a big problem with that. And so you have to have design tools, layout tools for chip design, which know about all of those rules and what the foundries can do and make sure that you obey all the rules that you get what you expect to get. So there's a whole very interesting niche there. We think it's growing and we think it's about to explode. So we're really trying to push hard in that market. Then just last year, this is just an internal organizational change because I'll talk about these so you know what I'm talking about. In 2019, we formed two groups. One is called the Photonic Solutions Group. That's the RSoft and Phoenix design teams. They're focusing really on PIC design as well as the device design and tighter integration with Synopsys design tools. And then the part that I'm a part of, which is the Optical Solutions Group, which is the LucidShape, LightTools, and Code 5 design tools, which are more the ray tracing kind of system design tools. And it seems to make more sense to divide it up in those ways. We still work with each other. We still know each other. We're still friends. But internally, we made that distinction. Okay, so a corporate overview. Synopsys is actually that's probably one of the largest software companies you've never heard of. We have revenues in fiscal year of 19 of $3.4 billion. We're the 15th largest software company in the world, I believe. We have over 14,000 employees, over 3,000 patents, and over 130 offices. And you can see on the chart there, we've been growing steadily since 2010, at least since when we joined. Although we don't take any credit for much of that anyway. Our part's very small. You can see here a map of sort of, where everybody's working in the world that works for Synopsys. Most of the engineers are here in the United States. We've got a large presence in Europe and India, and then a smattering around the world, China and Chile. We've got a big office in Armenia that does work. Anyway, so we're all over the world, very broad portfolio. The primary design work for Synopsys is in chip manufacture. That's their business. EDA software, electronic design automation, and they've also gone into software security now. But if you're making a chip, if you're designing a chip, you need to verify the mask, you need to design it, you need to verify it's going to work, you need to make sure that the foundry can make it, and you need to make sure that the mask that you've created based on that is correct, and all that takes a tremendous amount of software to verify and to go through, and that's the primary business of Synopsys. So you can see why the PIC actually fits in very well with that model. Now, as for the Optical and Photonics Solutions Group, I think we've already covered this. These are the basic tools that we provide: Code 5, LightTools, LucidShape. And then for Photonics Solutions, there's the RSoft design tools, device tools, the Photonic system tools, which we'll talk about, and the PIC design suite. And there's another category here which we haven't talked about, which is optical engineering services. We started out all those years ago as Optical Research Associates, really as engineers under contract. We take contracts for doing optical engineering jobs. That's how we started, and we still do that today. We've carried that all the way through. And so we provide optical design services for imaging, illumination, and systems engineering work under contract to various people. So if you have a job that you don't have a staffing for, and you need an expert to come in, maybe you don't have enough of work to keep a full-time person busy, but you still need the design done, you can come to us. We'll work out a contract and do the design for you. Or if you have overflow work, that kind of stuff. So we really have a very broad range of jobs there. We'll talk about that a little bit later. These are our offices. Not all of these buildings are, we don't take up all these buildings, actually. We take up a tiny portion of most of them. Pasadena, which is where I'm located, we have 51 staff. That is our headquarters for the optical solutions part of it. And then we have an office in Marlboro, where we have 9 staff. That's actually not the building. That's the old building. They just moved. I have to get a new picture for that. Tucson, we have a couple people in the Tucson office, 4 staff altogether. A couple work in that great big building there, so we only have a couple offices there. Austin, New York, we have 12 staff. That's the RSoft design team. Paderborn, Germany, about 16 staff there doing the Lucid Shape design work. And Enschede, the Netherlands, we have about 28 staff there, and that would be our Phoenix design team. And we have 12 staff that work from home. But then I put a parenthetical comment. Actually, all 132 of us are at home at the moment. So, or nearly all of us anyway. But I do like looking at pictures of the building because it's a little nostalgic at this moment. I'd like to go back to work in my office. So we have, that's where we are, that's our people. But then we have more, okay, because we have distributors across the globe to distribute our software. Not just distribute, so they're not just salespeople, but they're also, a lot of them do tech support. Some of them do very detailed tech support and engineering support. So it's like having additional staff, right? Because one of the things we sell with our software is technical support. You don't buy the software mostly. What people do is they lease the software. And what they're leasing is all the updates, and they're leasing technical support. So that's an important part of what we provide. We want to provide that support in country as much as possible, and we want to provide it in the language of the people that are the language our customers speak. So where we can, we develop our technical teams there through our distributor network to provide that kind of support, and then we backstop them with our staff here in the United States. So let's talk about the products. I'm going to go through these fairly quickly because some of you might be very familiar with these. Some may not, I don't know. So Code 5 is really for imaging optics, anything that makes an image. Cameras is kind of a smattering of things we've worked on. Microscopes, head-up displays, excuse me. Lithography is a big business for us. Any kind of camera, binocular, that sort of thing. Anything that makes an image. So code 5 is it models the system. It is sequential, so that means primarily sequential. So that means the light goes from the object to surface 1, 2, 3, 4, 5, and to the image, and in that order. And it has a lot of tools for simulating the image quality and a lot of built-in optimization and tolerancing tools, which are tuned for imaging, or at least for, if not imaging, for visual, for visual systems as well. So those that are collimated, it's the same thing except in angle space. And so for those systems like binoculars where you've got an eye in there, okay, it's a little different, but it's still, we call it an imaging system. We've got a lot of tools to support manufacturing, cost reduction, as well as prediction of the effects of manufacturing, such as tolerancing. A couple of the industries we're fairly well established in. Well, first of all, microlithography. We do a lot of business in the microlithography industry, very precise industry. They have a lot of lenses. They need high accuracy. And we also need modeling some of the wave-like natures of light, and it's fairly sophisticated. So we've got a lot of tools for this sort of application. We've been in this industry for quite a long time. Camera systems. Okay, here's we always say we were involved in the Hubble fix, not the original Hubble. Well, they might have used it to design the initial Hubble, but they didn't use it to make it. So if you'll recall the Hubble, that was actually back when I was in graduate school. They were fixing it. They designed it. It was a very simple design, essentially, pretty standard telescope setup, but they screwed up the manufacturing for various reasons. They built it flawed. They got it up there. They turned it on, and they got this kind of image that you see here, which is somewhat less than what they had expected for this kind of a project. So they panicked, and they eventually figured out what went wrong and what they needed to do to fix it. And we were involved heavily in the verification, design and verification of the fixed system. And so here it is after it's been fixed. They actually put in another mirror in the system, which had the opposite aberration as what they felt like they had polished into the first mirror. And so they were able to correct it, or at least mostly correct it. And they've been doing a lot of good science ever since. All kinds of other camera systems. These are kind of interesting in that these are all actually out of our student design competition. We run a competition every year for students. There's some money involved. And so if you're doing work with Code 5 and you've got some interesting results, or if you're doing with LightTools, either one actually, you can submit your design to our design contest and possibly win some money. And so these are some of the designs we've seen over the years from that competition. Microscopes, of course, and telescopes. This is actually a PSF function from this aperture. Okay, this is obviously not an airy disk. Okay, and this is on a log scale. That's why you can see all the detail down here. But you can see this is a very interesting pattern, and that's from this. This is from the Keck layout telescope, because of all the aperture is not round, and of course it's got all these little gaps in it, which give you all sorts of structure in the point spread function of the telescope, and we were able to model that as well. You can also then, of course, take one of these little segments and maybe misalign it slightly and see what happens to the PSF. All kinds of interesting analysis you can do there. There it is right there. So we've taken one of the mirrors and radically misaligned it, and just so you can see what happens to the point spread function. Well, not good things, as you might imagine. All right, so complex mirror shapes, all kinds of beam propagation. We have a very nice beam propagation tool, which was used in the NASA Planet Finder mission, which gives us a very high fidelity diffract enhancer, which I think may and very well be what this is actually output from, where we propagate the beam through complex systems like this, even if the diffraction occurs somewhere far away from the pupil, and we can get a point spread function result from even complex systems. Photonics, which is where I did some of my work, including fiber coupling and some other applications. And then a lot of other stuff, and we're just going over this very briefly. The second tool is LightTools. This was developed, like I said, in 1995. It is actually is roughly the same order of magnitude as far as number of customers and revenue for us as Code 5, so it's grown into a very mature product. It covers any kind of system where you're looking at light as an illumination medium. So we're going to illuminate systems, any kind of, you can see projectors and backlight displays and lighting. Runway lighting, we've got some tools specifically designed for people doing runway lighting because there's some very specific measurement requirements for that. So we've got some tools we built for that. Street lighting turns out to be another one, which is actually very difficult to do. It has a lot of very weird sort of requirements that you have to kind of get into. You have to be kind of part of the priesthood to appreciate some of the requirements for street lighting. And it's really impossible to do those analysis without some kind of a software tool because it really requires quite a bit of computation. So we've got some of that in there as well. Phosphors too. LightTools is a software that integrates 3D CAD, optical modeling, modern user interface. Okay, especially built for illumination applications. So we have it's more like a CAD kind of an interface. You build it, or you can actually build things in CAD and link them in to LightTools. And then use that. You apply optical properties to those models, to those surfaces, and then you put sources in there and receivers, and you run your Monte Carlo ray tracing, which is like 10 billion rays or whatever it is, not 10 billion, but you run millions of rays, and you catch the rays on the receiver, and you get an idea of what the pattern will be when you finish. We do a lot of work in the LED design industry, so a lot of the main manufacturers use our tools, not only for designing the chip and the phosphor around the chip, but also the secondary optics and predicting performance. This is an interesting picture here. Oops, sorry. The picture of the LEDs up against the wall. We do have a photorealistic rendering package, which we've had for quite a long time. And we wanted to test it against reality, so we actually built a step like this with 2 white walls, and we got some colored LEDs, and we took photographs of it, and then we simulated the whole thing in LightTools. This is actually a simulation out of the tool itself, and it was a very close match. So that's where that picture came from. Other kinds of applications, projectors, including these little micro mirror displays, the MEMS displays. Okay, so here's a MEMS mirror display. In order to do this, you can actually use our texture feature. So we have a feature to put textures on surfaces. We can put millions of textures, repeating textures, and we can also move them individually. So you're actually able to put millions or tens of millions of textures, little mirrors on the surface, and you can individually address each one. So you can go in there and you can tilt some and not tilt others, for instance, and see what the pattern then looks like on the screen. We do a lot of business in backlit displays, have for a long time. Not so much OLED displays because there's a lot less sort of optical components built into an OLED display. It's really just the OLED itself. But for those who are just it's like edge-lit, backlit displays, which are still very common, we do a tremendous business with them because there's a lot of work in designing this. And one of the biggest things that you have to do with these is design the textures. So what we do with edge-lit displays, you inject the light. So if we're looking at this little green picture here, there's an LED. This particular one has some 45-degree cuts to it. We've got an LED here, and there's a matching one over on the other side. The rectangular bit here is the display part, and there are textures there to extract the light. So the light guides is injected here at the LED. It guides through the plate. It bounces around through the plate at TIRing basically as it goes, and as it hits these little textures, the angle of the reflection changes, and hopefully those rays will un-TIR themselves and come out of the light guide to be seen by the user. And of course, in this particular case, the size of the textures is being varied as a function of position across the backlight. Of course, the larger the texture, the more light you would expect to extract in that location. The less light you expect to extract. So in the places on the light guide where you have a lot of light present, so things that are right in front of the in front of the source, you would expect to have very small textures. And in places that may be down in the corners where you don't have a lot of light running around, you may have larger textures to extract what you do have. And of course, they all play off one another. And we have a lot of tools for trying to figure out what that pattern should be, both in size of texture, or you can vary the number of textures you have in a particular area. And so that's a whole a whole line of business there where we're trying to figure out how to make the pattern usually uniformly lit. Doesn't have to be, but usually uniformly lit across the backlight. Do a lot of business in general lighting, especially the higher end general lighting. Something other than just placing a bulb in a fixture and letting it shine around the room, but in those more higher end, where it has more design work involved in them. We do some stray light calculations for things like cameras and this sort of thing. This is out of a stray light paper that I gave a few years back. This is actually my birthday cake. We have a rule at Synopsys: you can only use pictures that you actually have rights to use. And so I couldn't grab anything off the web, but I just finished my stray light talk and it was my birthday. And so I went upstairs and my wife had baked me this lovely cake and she brought it out and I took a picture with a well-known cell phone camera, which I will not say what manufacturer, but I saw these beautiful ghost images here, and actually there's a stray light image right there. I got very excited and had my piece of cake then ran downstairs and put it in my presentation. So, but anyway, we do this kind of analysis. We've got a lot of tools for trying to track how the light goes through the system. Also do some work on renewable energy, both heliostats as well as just solar collection. Okay, moving on to Lucid Shape. Lucid Shape is for the design of automotive products. So we have 4 tools there: Lucid Shape software, the plain Lucid Shape. We have one that's now mounted on CATIA, so that's Lucid Shape CA V5 based. We have a light, which is just for displaying the data. And we have a Lucid Drive, which is kind of a cool tool where you can take the headlight you've designed, put it in a car, put it on the road, and actually drive around with it, which is very good for especially the latest generation of headlights, which are these sort of what they call pixel light displays or active displays, where you're basically on high beam. The car detects another car coming. It then dims that region, not the whole region, but just the region around the car. It tracks the car as the car goes by so that you don't blind that driver, but everywhere else is lit. These are on high-end cars right now. I expect you'll see them on every car at some point, or on many cars anyway. And so if you want to test that, how does it work? How well does it detect? You can put it in Lucid Drive. And here you can see a picture from that where you can see the red boxes are the detected cars. And then the pattern is then modified using either an array of LEDs or MEMS or some other mechanism for dimming just that region of the headlight pattern. Lucid Shape is actually a lot like LightTools in a sense. It's like a CAD-like environment, and you put on optical properties onto the surfaces, and you put in sources and you put in sensors and you run simulations and you see what the output is. But it's got a lot of tools that are really specifically designed, especially for the headlight designer, because actually designing headlights is a real art. Because especially low beams, not so much high beams, but low beams for sure, because you've got cutoff lines and you've got fingers that have to stick out and you've got all kinds of regulations of how much light can and can't be in certain places, and all of that has to be tested. You make sure you have plenty of you'll still be within regs. So there's a whole art to that, and there are a whole bunch of tools that you need to have for measuring that and seeing if you got a good design. LucidShape CA V5 based. This is one of our newest products. This is basically LucidShape mounted into CATIA. So a lot of our users in the automotive industry, they use CATIA. CATIA is a CAD program. Has a lot of product life cycle management software involved. So it's usually used by larger companies because it's very expensive. But for complex projects like automobiles and aircraft, that sort of thing. And so being able to do the design inside of CATIA, this is what they're familiar with, and they've got the license. They want to keep it in that realm. So having this available to them is really very useful, and we've generated a lot of interest, and we're starting to sell quite a lot of copies of it. Lucid Drive, I think we've already talked about. This is a way of sort of basically taking the system and driving through a road and seeing how the headlights behave in an actual situation. Now let's talk a little bit about the RSoft products very briefly, because I'm not an expert on these, but there's a lot of applications we use for RSoft, including optical communications, optoelectronics, semiconductor manufacturing industries, and so forth. But again, the domains have to be very small. We have a number of tools in the RSoft suite. We have the passive design suite. This is one of my favorites because I understand it pretty well, and it's always easy to pick out. But this is a ring resonator. So this is used as a kind of an add drop, selective for particular wavelengths. So on the left-hand side, you'll see we have a fiber. These green and blue light and dark pieces are actually the representative of the electric field. So both positive and negative, the wave as it goes up and down. And here we have a ring. These do not touch, but the wave couples through the evanescent wave, and it couples in here. And if this ring is the right size and the wavelength's correct for the size, then this will be a driven oscillation rather than canceling, and you'll get the energy will couple into the ring fairly strongly. And then over here we have another fiber which then again picks up the evanescent wave, and the power will couple out of the ring back over into this fiber. So it's kind of cool. And unfortunately, I don't have the video of this, but there's a video where everything goes wrong. But I think you can imagine this are really useful for modeling. Couplers, decouplers, gratings. There's a lot of tools for looking at the output from this. We also do active device tools. So if you have like a VCSEL laser, here's a buildup in our CAD tool that goes with RSoft of a VCSEL. Here's it's a cross section. Actually, what you're looking at is a cross section. This is the active layer, that white layer there. That's the active layer, and then you can see the mode, a cross section of the mode as it goes through the laser. And eventually, I believe this is the output over here on the right-hand side. So we have tools for both active and passive devices. The PIC, I'm not going to go through all of this, but basically, the idea behind PIC is you need photons instead of electrons, as I said. And of course, instead of having right-angle things, you have to have bendy sort of light guides that can handle photons, so the photons don't leak out. You have to know not only what the photons are going to do, but you also have to know what the foundry can do. You're going to go to a foundry, you're going to make this design, you're going to go to one of a couple of foundries that exist in the world for making this. The foundry has certain rules that they have to obey, what things they can do. Your tool has to be aware of those rules so that you can build within what that foundry can make, okay? And you have to then make sure that what you've designed will work. And so that's the business of OptoDesigner. We also have another tool that came out of the RSoft team called OpSim Circuit. And this is kind of a way of doing a schematic layout of your optical system, optical network system, and you can put devices in there, okay? So you can put an amplifier, or you can put a source in your fiber network, and you can wants to build up the network, how the optical signal goes through the network and comes out the other side. And so what you need to do is you need to know how your device is going to perform for a given input, what's going to be the output, the device and pick, and then you can place it into a larger scheme where you have a network. And then because the OpSim circuit knows about the internal workings of your device, it knows how it performs with input and output signals. And so you can use that to sort of simulate the entire system and its performance. And this is used for actually one of the surprising uses for this is actually with the big data centers. And we do some business with the Amazons and Googles of the world that are running these enormous data centers because they've got networks that run between buildings and within the building, and they want to figure out how those networks are going to behave between their devices. That's an example. Some of the automotive companies are going towards optical fibers in the car because they're lighter and the data rates are faster. And they've got a lot of data now they've got to move as they go into smart cars. You're seeing a lot of data from a lot of sensors. It all has to be integrated and brought in. Copper is heavy, and they don't want that. So they want high data rates. So they're looking at going to optical circuits for that. So those are a couple of applications for our OpSim circuit product. As I mentioned, engineering services, we've never really forgotten our roots. We are the largest independent optical design group in the US. We have 9 engineers, at least at the time of this writing, and 6 of those have PhDs. Broad range of expertise in imaging, illumination, and optical systems. We've got thousands of projects that we've done over the years. And one of the things that gives us as a company is a unique perspective on, I guess I can let her in, a unique perspective on the use of our tools, because we have in-house people who are doing cutting-edge research with our tools. And they give us a lot of feedback when they don't like something, or if we have a question, how should this behave? They also are able to feed in a lot of expertise because they've been here for years and years, and they have a lot of expertise in how to design systems. So if we can take some of that knowledge and build it into Code 5 and LightTools and LucidShape, we can make our tools better and hopefully give that expertise a broader exposure, so that designers who haven't been working in the field for 30 years can maybe benefit from some of that knowledge. So we still think it's really important to have that team. Technical support, as I said earlier in the presentation, one of the things we're releasing is not just the software and access to the software and updates, but also access to technical support. We don't want people banging their heads against the wall over a problem that can be solved with a simple email. And so part of that whole thing is access to our tech support team. Currently have in OSG 12 people on the technical support team. These are all optical engineers. And this is how I started in the company. I started on the Code 5 technical support team. They're staffed by optical engineers. It's their business to do this stuff. It's not just some guy with a manual, okay? We have, more than 40 years of hands-on experience in design work. We have 10 engineers. There's a couple who are not engineers. 10 engineers that have advanced degrees. 6 of them have PhDs and 4 have master's degrees. And they're from schools like the University of Arizona and Rochester and Creole. Rensselaer. Those are, I think, the 4 major colleges we have from. But they're all trained optical designers. That's the point. And they're available for questions, not 24/7, but they're available during work hours over a period of about 12 hours of the day. We try to get as much rapid response as possible. Sometimes it's not possible. Usually we try to answer the great majority of the questions within 24 hours. And of course, you can always call us. This is also the team that does on-site and scheduled trainings. We provide expert customer-focused input and documentation support. So we support our testing team, and we support our documentation team with people they can ping who are in the business. And we also do things like what I'm doing now. So this is kind of still what I'm doing. I'm an applications engineer. I actually head up the application engineering team, and my people do this sort of webinar that we're doing today. I'm doing another one tomorrow. I'll show you the details on that, as well as go out and see customers and get their input, help them out, that sort of thing. So, sorry, that was a kind of a missed title. We want to talk a little bit about software quality. We also have a fairly large testing team. Okay, and this is really important. We perform thousands of test cases on the software weekly. Okay, to confirm the reliability and accuracy of the software, I've got about each product has about 10 or 12 programmers. They're typing all the time. They're changing the software. They're adding features. They're all contributing. And the problem is, it's a very complex program. I mean, Code 5 has been around since 1975. LightTools has been around since 1995. Millions of lines of code. If you write something over here, you can easily break something over here, and you won't know it until a test breaks, or worse, a customer complains. Okay. And so we have a whole team that does nothing but run tests. They have automated test cases every night. We run thousands of test cases so that if something breaks, we find out about it, hopefully the next morning. And so the first thing the software engineers do when they come in, when they look at the testing report from the run from that night before, to see if something broke that they could have maybe caused a problem with. And it's a lot easier to fix it if you find it the day after you break it than if you find it 2 weeks or a month or 6 months later and you have no idea what broke it. So we really feel this is important, and we want to reduce the need for our customers to be our bug testers. We don't want that at all. And obviously some things go through. We do get bugs that get reported out of the field. We want to keep that to an absolute minimum. We're also working with the universities, which is more sort of targeted towards you guys. We have a university donation program. So if you're a graduate student, excuse me. So if you're a graduate student who's working on an optical project, we're doing research, you're eligible to use our software for free. These are full versions of the software. These are not student versions. They have all the capability, with the exception possibly of some of the translation modules, which we have to pay for. We owe a royalty on. But they do not come with technical support. If you write us, we'll try and do what we can do, right, if we've got time. But obviously our paying customers come first with that. But it is, like I said, a full version of the software that's available to you. We have a student design competition. This is the Bob Hilbert Memorial Design competition. It's run every year, so we notify the schools when it's coming out. And if you have a design that you've been doing and you feel we've been doing with our software, and you want to throw your hat in the ring for that design, there's some substantial money involved in that that you could quite possibly win. We have a customer support portal which is available for you to get all the training materials and a bunch of other support articles and videos. Videos we're actually starting to put on YouTube, so you should be able to get more access more easily to those YouTube videos. And student licensing, but student licensing and university donations are basically the same thing. Okay. Okay, engineering opportunities. So we do hire talented people. We're obviously not a huge team, but there's not a lot of people in the optical industry in general. And so the kinds of people we're looking for, we hire optical algorithm specialists, software development. We hire computer science people. So there's kind of two kinds of developers we hire. We hire optical experts, who help us with the physics, right, and making sure that the answers are right. And then we have software developers who are the kinds of experts who make sure that it works, that the software plays nicely with the operating system, and the distributed computing is working correctly, and the random number generators are really random, and all this sort of thing. So there's really two groups of people that have to work together. We have to both people who know about things like polarization, right, and diffraction, and we need a bunch of people who know about you know, how to make things really work on a Windows environment. We also hire software quality assurance engineers. These are the testing people. Um, and those kind of people are important to us, and we value them. And we don't have a great big team. We have about six or seven people that do that, but from time to time we'll need to add more to the testing team. And some people really get into that sort of thing and really like that. We hire customer application engineers. That's what I do. Technical marketing engineers. Those are both kind of the same thing. The customer application engineers will be more of your technical support team, and I've done that for many years. And the technical marketing people are more people who go out to see customers and do presentations. I write a lot of PowerPoints and example models and videos and this sort of thing to try and communicate with our customers, our existing customers, the new features and interesting tips and this sort of thing. We obviously have sales engineers that work with the sales teams, and we have people for the technical documentation specialists. We have engineering, as I said, but generally speaking, that requires a PhD and or outside work experience. So they're trying to hire people who've been out in the industry for a while, who've had a really good, solid background with that to bring in, because it's actually a very select group of engineers that do that. I actually didn't put it in here. I should have put it in here. If you go to our website, if you're interested in maybe applying for a job at OSG, we'd love to hear from you. The way to go about it is if you go to our website, which is actually www.synopsys.com/optical solutions. Then if you go there, there's a globe. There'll be a link at the bottom for global opportunities, global thing. And so you can click on that. Actually go to synopsys.com actually and just click on the careers link, okay? But you want to search on Pasadena or Austining. Those are your keywords, because those, you know, Synopsys is huge, and you're gonna search on, you want the opportunities to go to Optical Solutions Group. So the best way is to search on either Pasadena or Austining, New York, if you're into photonics. Okay, but if you're interested in a job with us at doing sort of ray tracing, Code 5 LightTools, LucidShape, search on Pasadena, and that'll pull up any job openings that we have that are currently available with the Optical Solutions Group. I did want to mention the upcoming webinar series. So we're all stuck at home right now, but we'll make sure that we able to go out to see custom webinar series where they can access information. This is starting tomorrow. I'm giving a LiDAR talk tomorrow, designing LiDAR with Code 5 and LightTools. And then you can see the rest of the talks are here. They're Code 5, some are Lucid Shape, some are training talks, and some are more like engineering case studies. Registration is free. Just go to www.synopsys.com, Optical Solutions. Click on the support link, then click on the training link, and then over on the right-hand side, there'll be this Tech Talk Webinars link. Or you can drop an email to support, and they'll send you this link here. That may be easier to do. Just LightTools_support@synopsys.com should do it, or code5_support. Okay, so then there's the conclusion slide here. Obviously, we're a well-established company. We've been around for a long time. Synopsys has, OSG has been around for longer, actually, as Optical Research Associates. We really are dedicated to providing excellent customer support. I know a lot of companies say that, but we really are. We're the kind of company where people tend to work for decades. I've been in for 2 decades. I'm kind of mid-range. There are people that have been in for 30 years. It's not uncommon at our company. And we really are very focused on trying to help our customers and make them successful with our products. So with that, I think I'm out of time. So I need to stop talking, and if you have any questions, I'd be happy to answer them.
Thanks so much, Jake. I really appreciated you sharing your experience and all the good information about Synopsys. There's lots of great things coming up for sure. We will be sharing the listing of the Synopsys talks that are coming up in our newsletter. And then I think we also will be sharing the information about the design competitions as well. So I'll communicate with you more on that, get all the details. We appreciate it. Does anyone have any
Okay.
questions? Feel free to unmute yourself if you'd like, or if you prefer, you can also post your question in the chat.
Jake, this is Amber. I just wanted to say thank you so much. This was an amazing talk, and I really enjoyed hearing about all of the history.
Great. Yeah, I'll make Amy. I'll make sure that you get the Hilbert Design Competition information. I think we may actually. God, I think we may actually. Sorry, I just saw somebody I recognize from a long time ago. Sorry, I think the design competition may be over for this season. It may be next year, but I'll make sure you get the information.
Very good. Thank you. All right. Any questions?
Hi, Harold.
All right. If there are no questions, then we'll go ahead and close up shop. Thank you, everyone who was able to join us. And Jake, I'm sure I'll touch base with you more after this. Thank you.
Okay, sounds good.
Have a good one.
Thanks.
Bye.